This is what I get for doing it as a Mac app, even though I normally do this demo as an iPhone app. Can I set the class on the first responder? I don't think I can, right? Yeah. Oh, the app delegate's down here. That makes more sense. It's already made the app delegate reference for me. So if I look at the app delegate connections, we can already see that they're... Oh, okay. I'm going to get rid of this because that actually doesn't make a lot of sense. Yeah, I should be messaging. The first responder is kind of they call it it's a proxy object for whatever object happens to be the first responder. By default, it's the app delegate, but you can actually change that. So it's probably more direct if I just directly message the app delegate. And you can see now it knows that slider change is the only outlet that the app delegate has, so I can just choose that one. And again, there's a couple ways I can do this. I can either go from the app delegate's outlets and pick the label outlet and go to the label. And the cool thing is you'll notice it knows what type that thing is, so it knows that I can't assign it to a slider because a slider isn't a text field. But I also could have just control dragged from here to here and then picked the outlet label. And now with any luck that should work. Hey, I don't know why it's truncating, but wait, why is it truncating? Oh, it's because the label's really small. Yeah, let's do that and make it center line because that's prettier. Yay! Okay, so that's your first really simple app that talks to its user interface. Exciting, right? Okay, so just kind of a little bit of cleanup of just some basic concepts of how an app is structured. There's a class NS application that you'll never make, that's the system that makes for you when your application gets launched, and it's responsible for managing the run loop of your application. So on OS 10, this basically means it's going to wait for mouse events and key events, and then dispatches those events to the object that makes the most sense. And they're all of subclass NS responder because they respond to some input. And like I mentioned, the NS application owns mainmenu.nib, which is the zip file that contains the menu bar and the main window, usually. An important class that we'll come back to a lot is NSView, which is the superclass of all views in Cocoa. It has a position in size, which you can query for frame, which we'll talk about a little bit more later, but the idea is basically represents a rectangle in space. Views can have subviews inside of them, so that way you can have a hierarchical structure of views. And this is very often subclassed, and I think we do a subclass of that in this lecture? In this lab, I mean? Yeah. Yeah, so you'll get a flavor of writing your own view class in this lab. Okay, and then NSWindow manages every window in your application, and it has a single subview, which is its content view, which usually you never modify. You just add things to it as you make them. The window usually makes its own view, and you can just kind of add things to it. So here's an example of a view hierarchy. We have a window which has its content view, which contains a box and this label down here, and this box contains a text label. So the hierarchy hopefully is pretty clear. And there's a method on view called subviews, which gives you an array of all of the views that view contains. You can also ask for superview, which gives you the parent view of that view. Obviously, there's a lot more, so I'd recommend if you take a look at the view documentation to get in the sense of all the different things you can ask about a view, because there's lots. So the two widgets that I put in our interface are also subclasses of NS Control, which is a special subclass of view that basically has some concept of value. So this is where you're going to, all of your buttons, all of your sliders, all of your text fields, all those kind of things, those are going to be subclasses of NS control, because they're controlling some small piece of data that's whatever their value happens to be. And NS control defines a bunch of methods like int value, like float value, string value, bool value, so that you can ask these controls for their current value. And you can also set their current value. Okay, so delegation is a concept that people find very, very complicated, and I'm going to attempt to dispel that this semester. Because it's an extremely common and very powerful pattern in Cocoa. I actually have a whole lecture devoted to delegation, but I'll just kind of give you a taste of what delegation is like. So it basically it's a similar concept to English has the word delegate, which is to basically say to give somebody else a job that you have to do and have them do it for you, which is more or less how delegation works. The idea is that you have some object that needs something to get done, but rather than do it itself, it delegates that job off to some other object. One reason that's really useful is there's a lot of really common controls that contain, for example, a whole bunch of data. Like you have a table view that has a whole bunch of, a whole mess of rows, and it would seem kind of redundant for every time you want to make a table view with your own custom data in it to make your own subclass of table view, specify all the different stuff that's in it. So rather than subclass table view, you can just create a table view and then say some other object is its delegate, which is responsible for giving back all that data as it's needed. And that's kind of the idea. So when an object needs something, it notifies its delegate through some delegate method, and then that delegate object is now responsible for doing whatever computation is necessary. As we saw, we have an app. Projects by default have an object called an app delegate, which is usually where it's kind of the starting point for your application. It's responsible for maintaining starting and stopping the application and quitting it and a lot of other things. The window delegate is responsible for managing resizing and determining when it's okay to close the window. And again, we'll talk about these more later, but just to kind of have the idea of delegation in the back of your mind and kind of, for now, just keep the app delegate as your kind of canonical example, because that's kind of, it's responsible for handling things like opening and closing your application. And there's a lot more that delegation can do, and we'll see that in a couple lectures. So here's basically the life cycle of an application on Cocoa. The application starts, it will load your main nib. If you have one, you can also set your application to do it by hand, but that's usually a pain. And then it kind of just spins in this run loop where it waits for an event and handles the event. Then it's done, process the event, wait for another event, handle the event. And your application may be doing some other number crunching in the background, but that's the basic idea, is that it's just sitting there waiting for an event, then some event happens, you do something with that event, update the UI if necessary, update the model if necessary, and then wait for another event. And then at some point the user hits Command Q and your application quits. So for example, your delegate, when the application gets started, your application is designated as the delegate of the particular instance of NS application that kind of represents your app. So that delegate, when your application starts, gets the method delegate did finish launching passed into it. So that way you know, okay, I've started. I'm gonna do some setup work now to make sure that I'm ready to go. Present all, get all my windows ready, put all my windows on the screen, set up all my views, and the delegate also gets called when the application is about to terminate. So this is where you can do some cleanup, make sure that you freed all the memory that you've taken out, make sure that you save any state, so that way when you open up next time you can remember where you were, and that sort of thing. Is that it? Okay, so that was fairly high level, but we'll start to, hopefully the lab will give you some concrete work and do how you start designing, putting together a user interface and getting the code to talk to the user interface. So are there any questions? Yes?
What happens when the user force quits?
As far as I know, that sends kill to the application, which will not exit cleanly. As far as I know, that just stops execution wherever it is, and that you have nothing else you can do about it. You get no more. Your application runs no more instructions. That's end of application, basically. which incidentally on an iPhone is the same thing that happens when you minus the process in the application switcher. It just sends kill the application and quits it, which is not what I expected. I kind of expected it to send will terminate, but it doesn't. Good question, though. Anything else? Okay, so I will have the lab up in a few minutes.